Chu. This is bare algebra. We're going to solve systems of equations by using substitution. Make sure you subscribe to my YouTube channel and like this video so that I can bring you more algebra videos. So in example 1, it said if 2x plus 2y equals 6 is one equation and x equals 2y is the other one, can you find where they intersect, which would be the solution? So anytime that you have an x equals some expression or a y equals some expression, use substitution. So wherever I have the x value, which is right here, I'm going to plug into 2y. So I have my original equation here, only instead of an x, I put a parentheses, and the x value equals 2y. So I use the substitution property of equality for that. And then 2 times 2y is 4y. Now I've got like terms here. 4y plus 2y is 6y, and that equals 6. Now I use the division property of equality to divide both sides of the equation by 6. So I have 6y divided by 6 equals 6 divided by 6. So y equals 1. So that is my y coordinate. Now to find my x coordinate, I'm going to take either equation and substitute a 1 in for the y. So I take my second one because it's easier. I'm going to substitute y equals 1 in x equals 2y. So my y equals 1, not 1 inches, 1 in that equation. So x equals 2 times 1. So x equals 2. So my solution, I found the x and the y coordinates is the point 2, 1, and you write that like this. What does that mean? That means if I graph this equation and this equation at the same time on the same grid, they will intersect at the point 2, 1. Now how do I check that? So to check it, I'm going to take both of them and substitute this x value and this y value in. So I have 2 times 2, there's my x value, plus 2 times 1, and I say, does that equal 6? 2 times 2 is 4, 2 times 1 is 2. Does 4 plus 2 equal 6? Yes. What does that mean? That only means that 2, 1 is on that top line. Now we've got to find out if 2, 1 is on the bottom line. And I do that now by substituting in this equation, the x equals 2y, and I put the x in, which is 2, and I say, does that equal 2 times, I put my y in 1. Does 2 equal 2? It sure does. So when they both check, it means that is the solution to the equation. Now in example 2. In this one we said x equals something. Now we're saying y equals something because you can do it either way. So I'm going to take my top equation and instead of a y, I'm going to plug in the value that the second one said y was. So I have 3x plus 6 times parentheses. I substitute the value equals negative 54. All right, now I'm going to simplify this. 6 times negative 5x is negative 30x. That equals negative 54. So 3x plus negative 30x is negative 27x equals negative 54. If you struggle with this, I'm going to have more arithmetic lessons in tray arithmetic that I post, so make sure you subscribe to my YouTube channel. Now, I don't want negative 27x's, I want just an x. So I'm going to divide both sides by negative 27 by using the division property of equality. Negative 27 over negative 27 is 1, and 1 times x is x. And negative 54 divided by negative 27, and negative divided by negative is a positive, and 54 divided by 27 is 2. So I believe that my solution is going to be 2, but I don't know what the y is. So now what I have to do, I've got to substitute my value for x to find y. So I'm going to substitute x equals 2 in what equation? Which one's easier? The bottom one. Could you use either one? Yes, you could. So y equals negative 5 times 2. So y equals negative 10. So we're saying we believe that if we graph both of these equations on the same coordinate grid, that they will intersect in the point 2, negative 10. Prove it. So when you prove it, you have to check the solution. Okay? So here's my check. You have to take each equation and plug 2, negative 10 in. That is my solution. Here's my x. Here's my y. So let's go to the top one. 3 times my x value is 2 plus 6. My y value is negative 10. Does that equal negative 54? 6 plus negative 60. Does that equal negative 54? Sure does. So what does that mean? That means the point 2, negative 10 would be on this line when I graph it. But we don't know if 2, negative 10 is on the second line until we check it. So I'm going to take my y equals negative 5x and plug in. The y is negative 10 and the x is 2. And I put that little question mark up above it. Is negative 10 equal to negative 10? It sure is. And what does that mean? Since that point, 2, negative 10, satisfies them both, that is exactly where they will cross. And if you were to graph them, however the graphs look, that point right there would be 2, negative 10 by using elimination substitution to solve the system. I'm Mr. Chu. This is Bare Algebra, solving system equations with substitution. There will be a link up here to show you the solution to these two challenge problems. So I'm going to put challenge 1 here and challenge 2 here. And they will be problems that you could pause this video, try and see if you understand, and then watch to see if you did them correctly. I always like to offer a couple of problems for your check. So if you watched all the way through and you understood how to do it, this should be simple. So in challenge 1, we have two equations. 4x minus 4y equals 32. And the second equation is y equals negative 3x. In challenge 2, we're going to have x equals 3y minus 2 and 9x plus 6y equals 48. Try those two problems. You could pause this now after you write these down on a sheet of paper. And then when you play this again, there will be a link up here that has these solutions, a link down here that has all of the Unit 6 systems of equations and inequalities in it. I'm Mr. Chu. This is Bare Algebra, and I want to help you understand math better. Subscribe and join me. I'll see you in the next video.